All right, this is your Chapter 6 practice test. Number 1, complete the table for the function y is equal to y is equal to 0.4 e raised to the x power, round each value to the nearest tenth. So what you're going to do is you're going to take your calculator and you're going to plug in 0.4, and then you're going to take e and you are going to raise that to the x power, and in this case, the first one you're going to raise it to is the -1 power. So if you see that there, you have a -1, and what you need to realize is that you will have to round it to the nearest tenth. So that's one place after the decimal, and on that one there it would be 0.1. The nice thing is now you can just go back and change that and fill it in. So when we put in 0, you're going to see you're going to get 0.4. You put in 1, you're going to get 1.1 because it's again to the nearest tenth. And if you put in 2, you'll get 3.0 because again, to the nearest tenth, that 5 is going to make that 9 a 0, and that's going to make it a 3. So I just did all of them for you. So again, on this one here, you would put 0.1. This one was 0.4. This one here I just told you was 1.1. And this one here was 3.0. Okay. Remember, read the directions carefully when it tells you what to round it to. Okay. Number 2, it says match each of the equivalent values. So that means you're going to take those numbers at the bottom and you're going to plug them into the right ones. So let's just start with the first one here. We know that we want to find log the base 3 of 1/9. And remember, we can write this as equals to x. And then you can tell me that this base raised to this power equals this. So this base, which I just said 3 raised to the x power, is equal to 1/9. So now we're going to have to play around with that just a little bit to see what we can get. Well, we know that we have 3 raised to the x power, so on the other side we're going to want 3 also. So we know that 9 is 3 squared, but we also know that we can write that as 3 raised to the -2 power. So now that we have the same base on both sides, we can now state that our x's, our exponents, are going to be the same. So our x will equal -2 on this first one. So we're going to bring that in. All right. Same thing with the log to the base 3, 9 of 3, excuse me. So we're going to say 9 raised to the x power is equal to 3. Again, 3 is our lower number, so we know that 9 is 3 squared is equal to 3. And again, think of that as 3 to the first power. Remember, a power raised to a power, we're multiplying those. So we'll have 3 raised to the 2x is equal to 3 to the 1. So now on this one here, you can tell me that 2x is equal to 1. Solving that for x, we'll get x is equal to 1/2. So the second one here is 1/2. All right, let's go ahead and do this other one. Again, you can choose whichever one you want to do first. All right. And sometimes one might look easier than the other one. But again, on this one here, we're going to say 1/2 raised to the x power is equal to 1/4. All right. So remember, I can write 1/4 as 1/2 quantity squared. So 1/2 of x is equal to 1/2 squared. Again, our bases are the same. So we can state that our exponents are going to be equal. In this case, we're going to have x is equal to 2. So then by process of elimination, since we've already used -2, we used 1/2 when we used 2, the last one has to be -1. All right. Number 3. Find the inverse of y is equal to the natural log of x plus 4. So on this one here, remember what you're supposed to do is you're supposed to change your x and your y. So we're going to say x is equal to the natural log of y plus 4, and we're going to solve for that new y. So remember, a way to get rid of a natural log is to e both sides. So if I do that, all right, we know that the e and the ln, I just like to tell you they kind of cancel. So on this side here, we would have just y plus 4. On the other side, we have e to the x. So now to solve it for that new y, we're just going to subtract 4. So we'll get that y is equal to e to the x minus 4. All right. Now again, I've stated before, be careful when sometimes they'll give you the y equals, sometimes they don't. All right. If they don't give you one, put it in there. All right. Again, that's part of why I still correct them. Okay. So that is your answer for 3. Okay. Now on number 4 here, you're going to be looking at some of the properties of logs that we talked about. And you're going to use these two ones to solve for them. All right. So again, let's go ahead and look at them the same way. So I know log to the base 3 of 14 over 20. I can rewrite that using my properties. I can rewrite that as log to the 3 of 14 minus log of 3 of 20. That's for this one here. So if we do that, then we know that we're going to have 2.402 minus 2.727. And when you plug that into your calculator, you'll see that your answer would be negative 3.325. Okay. Log to the base 3 of 280. Well, you should know that 280 is equal to 14 times 20. All right. So now on that one there, we can write this as log to the base 3 of 14 plus log to the base 3 of 20. And when we add those two together, again, you're going to take 2.402 plus 2.727, and that will give us 5.129. All right. So those two we have done. Let's do one more, and then we'll see that the other one will just happen the same way. Now remember, this one here I can rewrite 196 is 14 squared. So this would be log to the base 3 of 14 squared. And remember, on that one there, since I have an exponent, I can bring that exponent out to the front. So to simplify that, I would go and say, I would have 2 log the base 3 of 14, which will be 2 times 2.402, which would give us 4.804. And then by process of elimination, or you could even notice that that is 400 is 20 squared, and that would give you 5.454. Okay, let's see, when we expand the logarithm, remember what that means is I have one L in there. I want to get one for each operation that I'm going to do. So the first thing you should notice is that we have that division sign there. So we can go ahead and say that we're going to take, and then when we expand it, we know that when we have the division, it's the same as subtracting. So we can say we have the natural log of 2 times x raised to the 4th power minus the natural log of y raised to the 7th power. Now remember, I just said the natural log of 2 times x to the 4th power, so I can even break that part up here. All right, so I can rewrite that as the natural log of 2 plus the natural log of x raised to the 4th power minus the natural log of y raised to the 7th power. And then remember, the last thing what we want to do is we want to bring those exponents down. So our next property would tell us that we can write that as the natural log of 2 plus 4 times the natural log of x minus 7 times the natural log of y. And that's our final answer for that one. Okay. The next one here is we're going to condense it. We just expanded it. Now we're going to bring all three. So we have 3 natural logs here. We're going to want to end up with just one. So we're basically going to go and do it in the opposite direction. So we have this 2ln5. Remember, I can bring that 2 up as an exponent. The same with this 2 with the natural log of x. So I'm going to put that one up, and then I'll have minus the natural log of y. Okay, now remember, your book likes you to say if you have 5 squared, you can write that as 25. So this one here I can write now as ln of 25. And remember, I can now bring these two together, the 25 and the x squared, because I'm going to multiply them. And then I'm going to say minus the natural log of y. So I had 3 natural logs, now I'm just down to 2. Last thing I need to do is that negative there will tell me I'm going to be dividing. So my final answer with 1 natural log will be 25 x squared divided by y. And that is what you would have to put in your calculator. I mean, in your big ideas, and it might or might not want the parentheses. I don't think so, but you'll find out. Next one is just simple. Put it in your calculator just the way you see it. So let's go ahead and do that for you. So log of 12 and 19. So I'm going to go, let's go back to our decimals. Let's get rid of this one. And I just told you we're going to write log. So let's see, I have log under miscellaneous here, I believe. Yep, there it is, log. I can do log to the 12. So I'm going to go 12, and then I'm going to go into my parentheses, and what am I supposed to put in? 9? 19. And again, they told us to round it to the nearest thousands, so that would be 3 numbers after the decimal. So the first one's tenths, the second one's hundredths, the The third one is thousandths. So we look at the one next to it, that's a 9, so that means we're going to have 5. So our answer is going to be 1.185. All right, so let's see number 8 here. Solve log to the 4x plus 3 is equal to log to the 7x minus 3. So remember, if we have logs that are the same on both sides of the equal sign, then all we have to do is we should be able to say that 4x plus 3 is equal to 7x minus 3. All right, so now I'm going to subtract 4x, and then I'm going to add 3. All right, so I just told you I'm going to subtract 4x. So that'll give us 3 is equal to 3x minus 3. So now if I add 3, I'll get 3x is equal to 6. And then I'm going to divide by 3. So I'll get that x is equal to 2. And again, if you have time, plug it in your calculator and see if it works. All right. Let's see. Number 9. Select the solutions of log x is equal to 2 minus log to the 5x plus 5. So we're going to kind of do the same thing here, and I'm going to, let's see here, I'm going to need a lot of room, so I'm going to take and use all of this part right here. So we have our log of x is equal to 2 minus the log of 5x plus 5. Okay, I'm going to get the logs on the same side, so I'll have log of x plus log of 5x plus 5, and that will equal 2. So now that I have the logs on the same side, all right, now I have that plus, so I can say log of x times 5x plus 5 is equal to 2. All right, so now there's 2 ways you can do this. Remember, if I have a log, all right, and I don't have a number down here, remember it's a common log, so you could write that as to the base 10 there. All right, and now once I have that base 10 there, you can think again what I keep saying, this base raised to this power, this base raised to this power equals that. All right, so 10 raised to the power of 2 is equal to x times 5x plus 5. Okay, so let's go ahead and distribute that x through. So I'll have 5x squared plus 5x, and that will equal 100. So now let's go ahead and take that negative over, the 100, move it over to the other side, so it now becomes negative, and I'm going to put it all on this side. All right, now if you think about it, I can factor out a 5 out of each one of these. So I'll have 5. What I'll have left in parentheses then is x squared plus x minus 20. is equal to 0. Now I would divide by 5. So I know then that my final part here is going to be x squared plus x minus 20 is equal to 0. And remember, let's see here. Since I have a coefficient of 1, I know I can write an x and I can write an x. Remember, I've told you before, look at this one here. If it's negative, which it is, we know automatically that one is positive and one is negative. Now you just have to think to yourself, what are factors of 20 that will give me a plus 1x? So that would give us a plus 5 and a minus 4. So again, plus that's 5x minus 4x gives us a positive 1x. Again, we're setting that equal to 0. So by the zero product property, we know that on this first one here, x has to equal negative 5. On this second one, x has to equal positive 4. All right? But now, since we had the logs here, we know that this log has to be greater than 0. All right? Again, if we plugged it in on either one of these, we would see that the one that will not work is the one that is negative. So let me go ahead and write this down for you, but x has to be greater than 0. So the only answer is going to be x is equal to 4. Remember, that one would be called an extraneous solution. So the only answer that you would be clicking on is this one here. Okay? Number 10 is a rather simple one. Okay? So remember, one of our properties was, again, I can natural log both sides to make it so that the x comes down. So I'll get x is equal to the natural log of 33. So that would be that one there. Okay, number 11 says solve 1/3 e raised to the 4x power is equal to 12 and round your answer to the nearest thousand. So again, that would be 3 decimal places on that one there. Okay, so remember, the first thing you're going to do is you're going to multiply both sides by 3 because you want to get e raised to the 4x by itself. So you do that, you're going to get 36. So just like I did on problem 10 there, all right, to get rid of that e, I'm going to natural log both sides. All right, so then again, the easiest way is just to think they kind of cancel each other out, which allows the whatever was your exponent to come down. So then on this other side, we still have the natural log of 36. And then to get x by itself, you're going to take and divide both sides by 4. So your answer is going to be the natural log of 36 divided by 4. Again, let's go ahead and go back to our calculator. And what did we just say we had? So we're going to go to our functions. And what did I say? We have the natural log. So you can see the natural log right there of 36. And then we are going to divide that by 4. And again, that gives us 0.89. It looks like 896. So we're going to say it's 0.896. And that's why you're going to plug in. So again, remember that problems are going to be very similar. Okay, so let's see here. Now, again, I just showed you one way up above here. All right, I just told you to put the 10 there and do this base raised to this power, right? So 10 squared is equal to that. The other way that you can do it, people, is if you have a log, remember, it's to the log 10. So I can actually multiply, not multiply, but put 10 on each side. All right? So it's kind of like doing that E, except this time here, we're going to just put 10 and the log are going to cancel. So let me put that back, sorry. So those two are going to kind of cancel, and that'll mean that we'll have 5x minus 12 is equal to 10 cubed, which is the same thing I would have had, like I said earlier, if I would have put the 10 here and said this base raised to this power, so 10 cubed is equal to 5x minus 12. So I got the same answer the same way. So now all we have to do here is say 5x minus 12 is equal to 1,000, because that's 10 to the third power. I'm going to add 12, so that'll mean 5x is equal to 1,012. Then I'm going to divide by 5, and I'll get 202.4, and that's the exact answer. That's what you put in, okay? 13, determine whether the function y is equal to 2 times 0.82. T represents exponential growth or decay. So remember, this part right here, that's kind of our B. And if it's less than 1, it's going to be decay. So in this case, it's going to be exponential decay. And then it says identify the percent rate of change of the function in part A. So remember, what this here states is that's our 1 minus r. So we have 1 minus r. In this case, since it's decay, that's why we have the minus r. And we're going to say it is equal to 0.82. All right, so now I'm going to subtract 1 on both sides. And then that'll give me negative r is equal to negative 0.18. All right, or think about it, r is going to be 0.18. That's in decimal. Remember, I need it in percent. So to change a decimal to a percent, I start at the decimal, and I move it over to, so we know that it's going to be 18%. So you just have to put in the 18 now. Okay? We're almost done here, people. Getting closer. So the population of a city is 81,000. And the annual growth rate is 0.9%. Write an equation to model the population y after X years. So remember, the rate here is 9%. I need to change it to a decimal. So remember, this time here, I'm going to take my decimal and I'm going to move it to this way. So I'll have 9% is equal to 0.009. So remember, our equation was y is equal to a, which was our initial amount, and then 1 plus or minus r. In this case, it's a plus r raised to the x power. Well, our initial amount is 81,000. And then we have 1 plus 0.009. We're going to raise that to the x power. But again, we can add that 1 plus 0.009, and that's what they're going to want you to do. And that will be your final answer. Okay. Number 15, the amount Y in grams of a radioactive isotope beryllium-7 remaining after T days is Y is equal to A times 0.5 T raised to the T divided by 53, where A is the initial amount in grams. What percent of the beryllium-7 decays each day? Round your answer to the nearest tenth of a percent. So there's two ways we can do this. We can look at 0.5, and remember the 53 there, you can either write that as 1.5 raised to the 1 over 53, or you can realize that that is also the 53rd root of 0.5. And when I do that, and I plug it into the calculator, either way, all right, I will get 0.987. Okay? Now when I get that, remember, that is my decay rate. If I say 1 minus R is equal to 0.987. So just like I did before, I'm going to subtract 1. If I do that, I'll get negative R is equal to negative 0.013. And then I'll get R is equal to 0.013. That's my decimal. So now I need to make it a percent. So to make it a percent, I'm going to take my decimal and I'm going to move it to the right 2 places. And that will give me 1.3%. Okay? So our answer here will be 1.3. Number 16, you deposit 1,200 in an account that earns 7.2% annual interest. Find the balance of after 8 years when the interest is compounded quarterly. So remember, on that one there, you're going to use the formula A is equal to P, which is our starting amount, and then we had 1 plus R, which is our rate in decimal. It's in percent right now, so we're going to have to change that, divided by N raised to the N times T power. All right. So when I do that, remember our T is going to be 8 years. Our percent, we have 7.2%. That is going to equal 0.072. And quarterly, remember quarterly is 4 times. Okay, quarterly, just think there's 4 quarters in a dollar. That's the easiest way to kind of think about it. So we're going to plug all of that in. The amount that we need is our A. We started with 1,200, and we have 1 plus 0.072 divided by 4, and then our N is still 4 up here, and our t is 8 years. So if we plug it in, and you can plug it in exactly like that, people, into your calculator, and you will get some number. But remember, we're talking about money, so it's going to have to be to the nearest hundredth. So you would get $2,123.78. Don't just give me a 7, and just don't give me 7, 8, whatever, anything else. Again, we're talking about money. Okay? And then finally, the last one, and I'll probably go through this tomorrow in class just because it's a different problem. But again, we're going to do the same kind of thing here. All right? So it says you deposit $800 in an account that pays 3.6 annual interest compounded quarterly. So again, it's going to be 4 times, and we're going to take our 3.6 and we're going to make it a decimal. And they want to know, when does your balance first exceed $1,200? All right. So on this one here, it is a little more involved. So we'll have our 800, and then we'll have 1 plus, well, all of this part is still the same. We're going to say 0.036. Remember, I changed that 3.6% to a decimal. And they told us it's going to be for compounded quarterly. So we're going to have 4 here. And this time we don't know what t is. That's what they're asking us. When does our balance? At what time does our balance exceed $1,200? So again, we want to know when it's going to be greater than $1,200. All right. So if I take that, I'll get 800. And again, I'm going to just go ahead and plug this as 1 plus, and you'll see it's a 0.009. For t, and again, we're going to say it's still greater than $1,200. Okay. So if we take this, we're going to first, let's simplify it one more time. So because that becomes 1.009 raised to the 4t is greater than $1,200. All right. So first thing you're going to do to simplify this is you're going to divide both sides by 800. All right. So now you'll have 1.009 raised to the 4t. All right. Is greater than, well, we have matching zeros here, so we can just say it's 12 over 8. And I would go ahead and leave it like that for right now, people, and see what happens. All right. So again, I need to bring this down. So to bring it down, I just have to natural log both sides. I'm going to natural log both sides. I'm going to natural log both sides. All right. So when I natural log both sides, that'll allow me to bring this down. So I can now bring that down in front. So now I'll have 4t, the natural log of 1.009. And again, we're going to say that's greater than the natural log. And if you did 12 divided by 8, you would find it's 1.5. Okay? So now I can, to get t by itself, I want to get t by itself. So to get t by itself, I'm going to divide both sides by 4, the natural log of 1.009. All right. So you plug that into your calculator, ladies and gentlemen. This part right here, you're going to plug all this in exactly the way you see it. All right. So why don't we go ahead and do that just so I can show you. All right. So I told you we're going to take the natural log. So again, functions, the natural log of 1.5. And then we're going to divide that by 4 times the natural log of 1.009. And as you can see, I have 11.3135. So remember, right now we're not sure, so let's keep it at 4 decimal places. All right. So we're going to say that t is greater than 11.3135 years. Okay, so now let's go up here and we're going to put 11 here. That is our years, but our months now, we're going to take this part right here, the 3135, because that's still in years. But if I multiply that by 12, that'll give me our months. All right. So let me go ahead and tell you what I did. So I'm going to tell you up here, change, change 0.3135 to months by multiplying by 12. Because there's 12 months in a year. So we have 0.3135 years times 12 months. All right. And we'll find out that that is approximately, well, they want a whole month. So we're going to say 4 months. All right. So now you're going to get that. Now here's the kicker. They want you to use the compound interest formula. So again, that's our 8,000 or 800, excuse me, times 1.009. And they want to know what that is. Okay? So we will take our 4. Now remember, we have 4 out of 12 months. And if we take that, you'll see that it is approximately 3,333 using my 4 decimal places. That's what they want here. All right, not the 3.135, but the 0.333. All right, because that's where it's first going to be greater than $1,200. And in fact, it becomes $1,200.85. So they will be a little particular on this problem. And it is the hardest problem on the test. But if you follow these steps exactly, again, I would write it down on this. That's why I gave you guys this and follow it. with the problem, because the numbers are going to change. All right. So that's it. Good luck. Study hard, and you should do fine on this test. Thank you, everybody.